Okay. So what I want to start with is alkenes. And to just recap, I'm going to recap alkanes very, very quickly. Then relate it to alkanes and alcohols and carboxylic acids. There is something I want to do after that. I'm not sure if we've got time, but if we've got time, brilliant. All right, alkanes. So um, alkanes are made from a carbon atom with four bonds. All carbon atoms must have four bonds. It's group four. I know I say this at the start of every time we do organic, and it is surrounded by hydrogens. This is the simplest of alkanes, and this is called methane. Let's just move that up. Let's call this methane. And I'm just going to put methane here. All that should make sense because it's what we did last week. Now, the second alkane, which will contain two carbons, is called ethane. And just to recap again how to draw it, I've got a carbon bonded to a carbon this time because there's two carbons, and each carbon must have four bonds. And this is H, 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 and H. Okie dokie. Now, if you look at each carbon, it's got 1, 2, 3, 4 bonds, and we're happy. If we write out their shorter formulas, this is one carbon and four hydrogen. Okay. This one has two carbons, C2, H6. The general formula is Cn for the number of carbons. To work out the hydrogen, take your number of carbons, times them by 2, and add 2. All right, and we did that last week, so hopefully that should be perfectly fine. Okay, now, from there, we're going to move on to alkenes. Alkenes, okay? Now, alkenes have a double bond, okay? Now, the way to draw the smallest alkene is ethene. It has to be because you need two carbons. And here is H, 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 H. Okay, now, and this is called ethene. Let's move this up here. And I want you to see how I draw them because you get used to it as well. This is ethene. The next one is going to have three carbons. That's called propene. And I want to be very clear about propene. And the common mistake that students make, 1, 2, 3 carbons. You only have one double bond in an alkene, just one. Where you put it is your choice. You can either put it here or you can put it there. Doesn't matter, but you can only put one. And we just write that out because this is such a common mistake. Only one double bond. Now, the hardest part in all of this, and God, this sounds really bad, you have to be able to count to 4. So I'll start with this carbon first. 1, 2, 3, 4. Pop H's where there's nothing on the end of my bond. This one here, 1, 2, 3. I only have one H on this, 4 bonds. On here, 1, 2, 3. Let's draw that, 4. Okay. Now we have, if we look at the general formula, we got two carbons, C2, H4, and I'm looking for number patterns. For this one is C3, H6. So the general formula is really simple. All I'm doing is times in this by 2. And the general formula is CnH 2n plus 2. 2n, not plus 2. All right. So this is alkenes, and this should be pretty much straightforward now because we did alkanes last week and we did a little bit of alkenes, but there you go. All right, next one. Alcohols. Alcohols. Now, alcohols, we're going to start with the littlest one, paint stripper, methanol. Meth, or to work out how many carbons you got, oopsie days, that doesn't look like anything. My elephant prefers bananas. That's one way to remember it. Methane, ethane, propane, butane. Methane 1, ethane 2, propane 3, butane 4. All right, we'll start with the first one. Methanol, 1 carbon, 4 bonds. It's really rather easy. Every single bond is a H except for one. That's an O bond H. This is methanol. All right. Let me just move that. This is methanol. All right. Methanol. Okay. Now, how you write the formula out for this is you deal with this side first, CH3. Then you pop an OH on the end. All right. I'm going to do second one with 2 carbons. This is E, so this is ethanol. This is the alcohol that is fermented, put in alcoholic drinks, used as a fuel, and used as a cleaner. Same thing, I draw 2 carbons, no double bonds. And any bond can have an O-H. And how I would write this? CH3. That one here, CH3. CH2. Here. And OH. So that's really rather tough, really rather different, but you'll be drawing a lot of them, so hopefully that'll make sense. Okay, the last one, and I want to really take time on this one. This is the bane of everyone doing GCSE chemistry. These are the carboxylic acids. Carboxylic acids. Now I'm just going to pause it here. I'm going to say to you, the reason why people find carboxylic acids difficult, they look weird. All right, they look very, very, very strange. Not to me. And the reason they don't look strange to me is I've been doing carboxylic acids for 41 years. Tell them that. I think it's 42 years. All right, so carboxylic acids look weird. All right, and I'm going to start with that's T. Methanoic acid. Oh my God, me pressing buttons on here is just hilarious. All right, methanoic acid. My elephant prefers bananas. Yeah, my elephant prefers bananas. Monkeys. Why am I saying monkeys? I don't know. This is 1 carbon. This is the hardest one to get your head around. C double bond O OH. This is how a carboxylic acid looks. And a short way of writing this is C double OH. This is the same thing. It looked weird to young students. This is 1 carbon, but it's only got 1, 2, 3 bonds. You need a 4th bond. And on that, I'm going to put a H. And therefore, in this short structured formula, I'm going to put a H. This is methanoic acid. We're now going to have a look at 2 carbons. My elephant is E, ethanoic acid. All right. So the way that I draw ethanoic acid is, this is 2 carbons, let's put that there. I've got 2 carbons, and that's how I draw them. And I leave it like that. I don't add any bonds on. I deal with the carboxylic acid functional group first, double bond O, OH. All right. So now this carbon has got 1, 2, 3, 4 bonds. I got to do nothing else. So this last carbon needs 4 bonds as well. So I put CH, H, H. So this would be my C double, oh dear, C double OH. It's not CO2H. You write it C double OH. And this is CH3 on the end. So you just write CH3 before that. Okay. So that's everything we're working on today. I'm just going to